Now, the fluence we receive from this object, that's the total amount of energy per square meter on Earth, is 2 by 10 to the minus 9 joules per meter squared. Its distance, its redshift, is 0.695, which corresponds, it turns out, to a distance of 1.3 by 10 to the 26 meters. So, what is the actual energy it put out? Remember, the fluence is equal to the energy divided by 4 pi d squared. So it's basically the same equation as flux and luminosity, only with fluence and energy, because it's not divided by unit time. So we can simply work out the total energy is 4 pi d squared times the fluence. We know the distance and the fluence, and that comes out as 4 by 10 to the 44 joules. Now that's one of those meaninglessly large astronomical numbers. I mean, yes, it's big, but what does it actually mean? Well, you can compare it to the luminosity of the Sun, which is 4 by 10 to the 26 watts. So what you can see is it's going to take a lot of seconds for that to add up to that. It's actually going to take about 10 to the 18 seconds of the Sun's energy output to add up to the energy of one of these things, which is, it turns out, about 3 billion years. So in a few minutes, the gamma ray burst put out the same power that the Sun will put out in 3 billion years.